Grounding fluorescent lights is an important safety measure, especially in older homes with mixed grounding systems. You've identified a situation where your new fluorescent lights are emitting leakage radiation due to ungrounded cases, resulting in a 60 volts alternating current difference between the case and ground. This is a common issue with ungrounded fluorescent fixtures. While the ballast company has indicated that the 60 volts alternating current is within Underwriters Laboratories safety limits, it's crucial to address the grounding issue for both safety and optimal ballast performance. The ballast circuitry is designed to function correctly when the case is properly grounded. Addressing your specific questions, firstly, regarding connecting to the existing ground wire. Yes, you can connect another uninsulated copper ground wire to the existing ground wire in the attic to ground your fluorescent light cases. It's paramount to ensure a secure and reliable connection. Use a wire nut or a crimp connector that is properly sized for the gauge of the wires you're connecting. A loose or corroded connection will defeat the purpose of the ground and could create a hazard. Secondly, adding a new cable from the service panel to the attic can be more challenging, particularly if your walls are finished. There are several options to consider. 1. Install an exposed conduit. You can run a new cable from the service panel to the attic by installing conduit along the wall. This method is less intrusive than fishing the cable through the walls, but it may not be the most aesthetically pleasing option. Consider the visual impact of the conduit run before proceeding. 2. Fish the cable. Attempting to fish a new cable through existing walls and ceilings is another possibility. This requires access to both ends of the cable run. It can be a time-consuming and potentially difficult task, especially if there are obstructions in the wall cavities, such as insulation, fire blocks, or other wiring. 3. Hire an electrician. A licensed electrician has the tools, expertise, and experience to safely and efficiently add a new cable from the service panel to the attic. This is often the best option if you're not comfortable working with electrical wiring or if the installation is particularly complex. Remember, electrical work can be dangerous, and it's always best to err on the side of caution. Now let's delve deeper into these options and related electrical safety concerns. When connecting to the existing ground wire, you must determine if the existing ground wire is adequately sized to handle the additional load from the new lights. The National Electrical Code, NEC, specifies the minimum size of grounding conductors based on the size of the circuit conductors. Refer to NEC Table 250.122 to determine the appropriate size. If the existing ground wire appears too small or flimsy, it may not be adequate. In this case, it would be better to run a new, properly sized ground wire directly back to the service panel. Also, inspect the existing ground wire for any signs of damage, corrosion, or loose connections. Repair or replace any damaged sections before proceeding. If you decide to run a new cable from the service panel to the attic, there are several factors to consider. Firstly, you must ensure that the new cable is properly sized for the circuit load. The size of the conductors must be adequate to handle the current draw of the lights, and the overcurrent protection device circuit breaker or fuse must be sized accordingly. Consult NEC Table 310.15b16 for ampacity ratings of conductors. Secondly, you must use the correct type of cable for the application. Non-metallic NM cable is commonly used for residential wiring, but other types of cable may be required depending on the specific installation and local codes. Thirdly, you must properly secure and support the cable along its run. The NEC requires that cables be supported at intervals not exceeding 4½ feet and within 12 inches of boxes, cabinets, and fittings. Use cable staples or straps that are specifically designed for the type of cable you're using. Avoid over-tightening the staples, as this can damage the cable insulation. When fishing a cable through walls, use a fish tape or wire to guide the cable. Be careful not to damage existing wiring or other components in the wall cavity. If you encounter any obstructions, you may need to cut access holes in the wall to facilitate the cable run. Be sure to repair any holes after the cable is installed. If you choose to install conduit, select the appropriate type and size of conduit for the application. Electrical metallic tubing is commonly used for indoor applications, while rigid metal conduit RMC or rigid polyvinyl chloride conduit. Rigid PVC is often used for outdoor or underground applications. Properly support the conduit along its run using conduit hangers or straps. Use conduit fittings that are specifically designed for the type of conduit you're using. When running a cable through conduit, be sure to use the correct number and size of conductors for the conduit size. The NEC specifies the maximum number of conductors allowed in a conduit based on the conduit size and the type of conductors. Refer to NEC Chapter 9, Table 1 and associated notes for conduit fill calculations. When working with electrical wiring, always follow safe work practices. Firstly, turn off the power to the circuit you're working on at the service panel. Use a voltage tester to verify that the circuit is energized before touching any wires. Secondly, wear appropriate personal protective equipment, including safety glasses and insulated gloves. Thirdly, use tools that are specifically designed for electrical work. Do not use tools that are damaged or worn. Fourthly, never work on electrical wiring when you're wet or standing in water. Fifthly, if you're not comfortable working with electrical wiring, hire a licensed electrician. Leakage radiation can be a concern with fluorescent lights, particularly if the fixtures are not properly grounded. The 60 volts alternating current difference between the case and ground that you're experiencing is an indication of leakage current. While the ballast company may say that this level of leakage current is within underwriters' laboratory's safety limits, it's still important to address the grounding issue to minimize the risk of electric shock and to ensure proper ballast performance. Grounding the light cases provides a path for the leakage current to flow back to the source, reducing the voltage difference between the case and ground. This makes the fixture safer to touch and helps to prevent interference with other electronic devices. The recommended steps to address your grounding issue are as follows. 1. Connect the light cases to the existing ground wire in the attic using a secure connection. Make sure the connection is tight and corrosion resistant. Use a wire nut or a crimp connector that is properly sized for the gauge of the wires you are connecting. 2. Consider running new non-metallic cable from the service panel to the attic using an exposed conduit or fishing the cable through existing walls. This will provide a dedicated ground wire for the lighting circuit and ensure that the fixtures are properly grounded. 3. If you are unable to run a new cable, hire a licensed electrician to do so safely and efficiently. A qualified electrician will have the tools, knowledge, and experience to perform the installation correctly and in accordance with the NEC and local codes. 4. Once the ground wire is properly connected, the leakage radiation issue will be resolved, and the ballast will function as intended. Verify the grounding by measuring the voltage between the light case and ground. The voltage should be close to 0 volts alternating current. In addition to grounding the light cases, there are other steps you can take to reduce leakage radiation. Firstly, use high-quality fluorescent fixtures and ballasts. Look for fixtures and ballasts that are underwriters' laboratories listed or certified by other recognized testing laboratories. Secondly, ensure that the fixtures are properly installed and wired. Follow the manufacturer's instructions and all applicable codes. Thirdly, consider using shielded fluorescent lamps. Shielded lamps have a metallic coating that helps to contain the electromagnetic radiation. Before undertaking any electrical work, it's essential to familiarize yourself with the NEC and local electrical codes. The NEC is a comprehensive set of standards for safe electrical installations. It covers everything from wiring methods to grounding and bonding requirements. Local codes may be more restrictive than the NEC, so it's important to check with your local building department to determine the applicable requirements. Remember, electrical work can be dangerous, and it's always best to err on the side of caution. If you're not comfortable working with electrical wiring, hire a licensed electrician. A qualified electrician will have the training, experience, and equipment to perform the work safely and correctly. They can also ensure that the installation meets all applicable codes and standards. In summary, addressing the grounding issue with your fluorescent lights is essential for safety and optimal performance. By connecting the light cases to a properly grounded circuit, you can reduce the risk of electric shock, prevent interference with other electronic devices, and ensure that the ballasts function as intended. Consider the various options for running a new ground wire, and choose the method that is best suited to your skills, resources, and the specific conditions of your home. And always remember to prioritize safety and consult with a qualified electrician if you have any doubts or concerns.